Today we're going to be looking at surface area, and I'm not going to lie, this can be a rather tough, tricky topic. So you're going to want to make sure that you're writing the formulas down. I want to do my best to provide a formula sheet in the description on the YouTube channel, but it's rather tricky. Like I said, you're going to want to make sure that all your work is in order, that you're taking your time. If you have the option to use a calculator, make sure that you are using a calculator. One of the things I find that with surface area is that kids tend to write their unit of measure cubed because it's so difficult. They think it's going to be cubed, but we are looking at area, surface area, so we're going back to using to the second power or squared in this case. So you may be asking yourself, once again, Mr. Small, when am I ever going to use this in real life? I will tell you this, there could be a point where you're not going to use it, I'm not going to lie, but if you're going to follow the jobs of engineering, construction, things like that, you are going to see this. It's going to save you a lot of money if you know what you're doing correctly. But at some point you are going to have to take some type of college course of some sort, or even higher level high school classes that will help you out with this. So just please take your time with this. Make sure that all your work is in order. Try and follow the formulas the best that you can. A lot of them are just jumping off of what we did with just basic area. So you'll see some similarities here, and we're only talking about triangular prisms, rectangular prisms, and our rounded ones are going to be cylinders. All right, we could go as far as doing cones and spheres, but we may save that for another video because this is so intense. Okay, so good luck. Please make sure that you watch the video a couple times if you're having issues. All right, the first thing we're going to look at is our definition here. So we're going to look at what's called a net, and a net is a pattern of two-dimensional figures that can be folded to form a 3D figure. So imagine that this piece here is our, this piece here is our pizza box folded together that you would get when you get it home. Now, if you've ever been to a pizzeria or have possibly worked at one, this is how the boxes look before they're folded up. So this would be the net. The same thing when you get a package from Amazon or something like that in the mail, and you break down the box, you're breaking it down to its net, to its two-dimensional figure. All right, and then the next term, which is basically what our goal is here, is the surface area. So surface area is the sum of the areas of the faces, which is the outer portion of whatever 3D shape you're talking about, or surfaces of a 3D figure. So let's say that we had this house here, and we had to figure out how much paint we would need in order to cover this entire house, including the roof, the side, and the front, and all that. So what we would need to do is find the area of this side, the area this, the area of the other side that we don't see over here, this side, and then this side that we don't see, and this side that we don't see, and then of course the back. So that's your surface area. So as you can see already, it can be rather difficult. And then the lateral faces are one of the parallelogram faces that connect the bases. So what would our lateral faces be here? Well, imagine that this goes back, that you don't see on the other side, right? Well, it basically would be everything except for the top portion and the bottom portions. It's all the sides. I'll do double arrows here. The back as well, that connect this. All right. And when I say the bottom, it's this part here. Okay. All right, and then our last word is lateral area, is basically referring to those lateral faces that we saw before and taking the sum of all the areas of those particular shapes. All right, but remember, when we're looking for surface areas, we're not just limited to lateral area, we're also going to be looking at the tops and bottoms as well. All right, so what we have here is our formula for the area, surface area of a rectangular prism. So we're going to designate this as our width. We'll designate this as our length, the 15, and this is our height. So it doesn't really matter what you designate as what, because commutative property says you can switch it up. So we have 2 times L, which is 15, and the width is 7, plus, and the reason we're doing 2 is because there's 1 on either side, all right, as we saw with our definition. And then 2 times 15 times the height, which we're saying is 9, plus 2 times the width, which is 7, times the height, which is 9. All right, so we calculate the two sides. We get 210 for the one, 270 or 210 for those two, 270 for the other two, and then 126. We take the complete sum of that, which is 606, and that is going to be inches, and we're back to squaring it because it's area once again. All right, the next shape we're going to look at is a cylinder. So the formula is right here. Definitely something you want to write down if you haven't done so already. If you look here, this portion is really just finding the area of a circle, which we've done before. And the 2 is being used because we have a circle on either end. All right, so that's similar. This part is completely new because it's a it's a circular or rounded type of surface, so that's a little tricky. But we're going to plug all our numbers in. Once again, you got to be careful if they're giving you radius or if that's what you need to look for. So we have 2. We'll use 3.14 for pi. Our radius in this case is the 6 feet. All right, plus 2 times 3.14 again, times the 6. And then our height, which I'll throw down here, is 8.3 that we're going to multiply by. All right, so let's see what that's going to end up being. All right, so after we do the calculations, this is for the 2 circles on either end of the cylinder. This is for the round portion. Imagine the label that will go around. We're going to round this off to the nearest tenth after we add it up. So it's 538.8 feet squared. Once again, remember it's squared because we were looking at area, not volume. All right, now this one is rather tough because we're looking at a composite figure, and there's some things that we need and don't need based off of the question. So it says the Playhouse is a composite figure. We see that we have a rectangular prism on the bottom and then a triangular prism on top. It has no floors and no windows, which means this bottom portion, which is right here, we're not going to paint that. We're not going to worry about the surface area of that because that is the floor. We don't need it. That's why it's in white. Okay. Same thing for the top part with the roof. This would be like the ceiling. Well, we don't need the surface area of that. So that's why it's in white. So you got to be careful when you're drawing your nets. So what they want us to do is find the surface area of the Playhouse. We'll look at this one first. So we're going to do 2 times, because there's 2 of them, 3 times 2. All right, we'll break each one of these up. All right, so that's this piece here and this piece here. All right, we're going to do that together. What we end up getting is 12. All right. Then we have this side here, this side here. Well, that is 4 feet by the 2 feet again. So that'll be 2 times 4 times 2. That ends up getting us 16. All right, and then the bottom part, we would normally do this by 2, right, because of the white part. But since we're only looking for the the bottom portion or the one side, we're not going to worry about doing both of those. All right, so then what we end up doing is we need 3 by 4, so that's, we're only going to do that once, remember. See, I must have made a mistake. 3 by 4, so that's 12 as well. All right, so 12 plus 12 is 24, plus the 16 is 40. So for the image on the left, we know that it's 40 feet squared. All right, so far we have 40 feet squared. All right, then we do our triangular prism, and remember the white part we don't need because that would be, imagine at your ceiling. We're only looking at the outer portion of the upper part of the house. So let's do the triangles. Well, there's 2 of the triangles, and remember the formula is half times base, which in this case is 3, times height, which is 2. All right, and the reason we're doing 2 of these is because there's 2 triangles. So 3 times 2 is 6. We cut that in half. It's 3, and then we multiply by 2 again. It's 6. So kind of crazy that we're going backwards. So that was for this and this triangle. All right, so we have 6 as one of our numbers. And then luckily for us, we only have this square here, or this rectangle here and this rectangle. Well, there's 2 of them. The length is 4, and then this 2.5 goes there. So it's then 2.5. All right, so we have 4 times 2 is 8. 8 times 2.5 is 20. All right, so we need the 20 and the 6. So our other portion that we'll need is a total of 26 feet squared for the upper portion. So this is something that you could see in construction, knowing what pieces you need and what pieces you don't need. So we add those 2 together, giving us 66 feet squared for our surface area. So just to review, this white part here, imagine that you're looking inside the house, right? That would be this part here, the ceiling part here that we don't need, right? This part here is the bottom part, the floor. All right. So that would be the floor here. We're not gonna paint the floor, right? And then let's imagine up here we wouldn't paint the inside of that either. Okay. So this is a tough one. Definitely something that maybe not as a middle schooler or a high schooler yet that you're going to use, but I guarantee at some point, especially if you're going to go into engineering or in real life construction of some sort, this is something that you're going to see.